Hi everyone, so this is the new channel that I am starting with. So for now, I would just start with Elasticsearch. So the aim of this video is to cover the entire Elasticsearch in through the summary. So what I have done till far, I would be covering in this video in a very short note. Okay, so. So let's start with what is the Elasticsearch. Okay, so Elasticsearch is basically a search engine that helps you to get some sort of to get the queries very quickly. Let's say if you are querying some table or database, then in the normal database it would take us time, like uh, uh, it would go through each record. Like in if we talk in case of DynamoDB, then it would go through each record and then try to find out the relevant results. What in case of Elasticsearch, it can do the things almost in the order of one time, means in constant time you would be able to get the results. So how, what thing Elasticsearch uses in its backend implementation? So it basically uses the Apache Lucene index. So this is inverted index concept. So what it does is, for each of the field it tries to store it optimally. Like what it will do is, let's say I have a whole text, whole summary, something like I am Puskal Goel. So what it will do, it will take each of the words I am Puskal Goel, and it would store the corresponding document, like first document, second document, and then like it would, the mapping would directly point to the memory. So and also besides this, so it is using BKD trees. So BKD trees is basically a advancement of BST. So actually one thing I forget is Apache Lucene index. Basically how it works is, whatever I have understood so far is, they used to store the segments in the index itself. Okay, so means they are putting some index, and then it would get divided into small segments. So these segments would get merged into themselves, so as to whenever required, like if the segment size is grower, or some out of memory error is there, then it would combine itself to other one so that it can perform well. Okay, okay, so we are done with the Elasticsearch thing. Now next thing would be, we would be discussing how we have to query the Elasticsearch. Okay, so means actually, unlike most of the databases, we have the power to choose what data we want. Like if we go towards SQL, then we have to write a query in a way that it should match the exact text of some field. But in case of Elasticsearch, You can even do the similarity search, like you can find out like what similar documents are there, so that you can index them. Why? Also you can search through the like what you can do is, let's say I have the summary field and there are whole lot of text like 100 words, 200 words. So but you don't remember the 100 words, so what you can do is you can put the some of the part whatever you remember, and Elasticsearch would do all the pre-processing for you. That is, I guess, one of the most amazing part about Elasticsearch. And besides this, like there is also the concept of the indices. So two things are there: Lucene index and Elasticsearch index. So Lucene index is the way Lucene index is the original index that we meant index to be index. Like it is used to identify some of the to identify the set of records, but it happens automatically. Like in case of DynamoDB, you have to select your index things, okay, primary something. But in Elasticsearch everything would be automated, okay. So Lucene index is the backend thing implementation of Elasticsearch that used to happen. But indexing for Elasticsearch is something kind of the table name, okay. So like in SQL or in even in DynamoDB, we used to identify via some name of the table that this is the data. But in the Elasticsearch it is called the index. Lucene index and index are different, okay. Yeah. And then there is a concept of pagination like other databases. So there are basically three ways. First one is scrolling. So it like with the search query you have to pass the scroll ID, and what it will do is whatever data you have fetched, you got like you got 20 records at first time. In the second time you would get the next 20 records. So for next 20 records you would get a scroll ID, and what it does is it would store the snapshot uh, of the scroll of the pagination thing that has already happened and where the cursor is currently. So that way it is some kind of time consuming, but it is still the efficient way. It's even not recommended, but it can be still like it can still be used. And the other thing is there is a thing called from and size. Like in this, so there are basically two things. So actually it is search after parameter. So in sort function you will pass something like I want let's say I want result on this column, but I want it to get sorted via this. So what you can do is you can set the size to 20, and then search after you can pass. Then what it will do is in the search after every time you have to pass like what is the last record, like the 20th record, what was that, okay. So we were talking about 20 records. So after 20 record, what is the 20, like 20th record, what was the field that is sorted, the value of that field, okay. Okay, so yeah. And pagination done. And also for deletion also, there is like, this is one of the most important thing, I think you should listen this. So for deletion, what Elasticsearch do is, if you would delete some document, it would mark it as deleted. What it won't be deleted, it would be marked as deleted. So when the query will run, it would just remove that particular document. That's all. And I think so it is going in the aspect of segment level. So I have just explained that there is leucine index and then there is segment. So like for every leucine index there would be some segments. Okay, so like segments basically do on the basis of the similarity of documents. Okay, so that for the Elasticsearch it can perform the things optimally. So like for deletion, it would remove the from the segment, but it won't delete. But after some time, the segment would get merged. So I think in that way, the deletion, like the the deletion can be done, like the things that have been marked as the deleted but are not deleted would get deleted when the segments get merged. Okay. Also, there is a concept of dynamic mapping. It is one of the most important thing. So there are several type of mapping. First is dynamic mapping that happens automatically, and it has a lot of options like numeric, date time, and there you can set true, and you would be able to detect fields automatically. Then there is other thing called as runtime mapping. Okay, no, not runtime. It is called explicit mapping. Runtime is there, but we would come later. Explicit mapping, actually, we used to provide the mapping because we know data, our data very well, and anyway we can't trust on the machine uh, to know our data well. Okay, okay, so we would pass our mapping, and like this is mapping is one of the most important thing for Elasticsearch. Okay, and then there is runtime mapping. Okay, so runtime mapping, in this you can add your field dynamically without getting indexed. So the thing, the fields that would be indexed would incur some memory, but in runtime you won't get much memory usage, but the search performance would be impacted through runtime. Okay, but you can do indexing of the fields in runtime mapping. Yeah, that you can do. And then there is a concept of SAR. I am working on it. I would Let's make this on the next video. It's already been too long. Thank you. Bye.